Hello friends, my name is Baji. Welcome to our channel. This is episode number 10 in our performance testing must-have skill series. In this video, we will continue to discuss some of the performance testing core concepts. If you are watching this series for the first time, please watch previous episodes of this series and continue these concepts. You can find the link to this playlist series in the description. We will begin by discussing the topics covered in this video. Firstly, let's explore the concept of SLA and its objectives. And then we will dive into the subject of requirements, differentiating between functional requirements and non-functional requirements and providing some examples. Following that, we will explore various types of non-functional requirements specific to performance testing. And then we will look into the different requirements to be gathered during the study and gathering phase. Last but not least, we will explore the various challenges encountered during the requirement gathering phase. With that said, let's proceed without any further delay and dive into this video. So let's discuss the concept of SLA and its objectives. So what is SLA? SLA stands for Service Level Agreement. Basically, it is a formal agreement between a service provider and its customers that defines the level of service that can be expected from the service provider. SLAs are used to build trust and transparency between service providers and their customers. They are especially important in situations where downtime, service interruptions, or performance variations. SLA serves several important purposes, and let's look at some of them now. Customer expectations. SLAs can help set clear expectations for customers or stakeholders regarding the quality and reliability of the services. Customer expectations for SLAs can vary widely depending on the nature of the service or product being provided, the industry, and the specific needs of the customer. If you take e-commerce platform as an example, customers may expect rapid processing, including confirmation emails and shipment tracking. They may expect 24/7 availability of the application to allow shopping at any time. Next one, accountability. SLAs establish accountability for service providers, ensuring that they deliver on their promises and meet defined standards. Accountability typically involves consequences, penalties, or compensation when service levels are not met. For example, a web hosting provider may offer a 99% uptime guarantee. If they fall short of this guarantee, they may provide a credit or refund to the customer for the downtime. Monitoring. SLAs provide a framework for monitoring and measuring service performance. It allows both parties to evaluate how well the services are being delivered. For example, monitoring SLAs can help the service provider detect and identify any service issues or bottlenecks in their system and provide a quick resolution to the customer. This way, they can maintain the quality and consistency of services. Dispute resolution. SLAs help to provide a structured and fair process for resolving disagreements or conflicts that may arise between the service provider and the customer regarding SLA compliance. These are just a few purposes, and there are many more. Overall, SLAs help organizations and service providers maintain accountability, trust, and efficiency. Now let's look at the topic of requirement. So what is a requirement? Basically, it is a documented statement that describes a specific feature or characteristic that a software system must have to meet the needs of its clients. In other words, clients' expectations are recorded in the form of statements. Requirements can be categorized into two primary types. Functional requirements. They are also referred to as FRs. These requirements describe what should the system do. Functional requirements usually specify the specific actions, operations, or behaviors that a system needs to demonstrate in order to meet user requirements. Non-functional requirements. Non-functional requirements specify how well should the system do to meet the client's expectations. Non-functional requirements help define the overall quality and the characteristics of the system. Let's explore some of the examples of the functional and non-functional requirements. The system shall allow users to log in using a username and password. In this case, the requirement specifies that the system must allow users to log in using their username and password combination. Another example, like users should be able to add items to their shopping cart. In this requirement, the system should allow users to add items to their cart. So if the system is working as per the above functional requirements, we can confirm that it meets these functional requirements. Similarly, when it comes to non-functional requirements, the requirements are like the system must have a response time of less than 2 seconds for 95% of user requests. That means the system should respond to user requests within 2 seconds. For example, let's assume that the user is trying to log in. So here the login is a request and the system should load the subsequent screens within 2 seconds. Another example, the system should be available 99.9% of the time. It means the system can have a maximum downtime of 0.1% of the total time. In a year, 0.1% downtime equates to approximately 8.76 hours. This implies that the system can tolerate up to 8.76 hours of downtime, and the remaining time the system should be available for the users. Prior to conducting performance testing, it is essential to understand the system's performance related requirements. Now, let's explore those different NFRs related to performance testing. As I explained in the past, performance testing is a subset of non-functional testing. Therefore, performance testing NFRs are subset of non-functional requirements. They specifically address the performance aspects of a system, application, or software. Performance testing non-functional requirements play a crucial role in guaranteeing the system functions effectively and fulfills user expectations expectations regarding speed, scalability, and stability. Before diving into those requirements, let's quickly understand a couple of key aspects. We should always try to avoid gathering abstract or high-level requirements. They may describe performance goals in broad terms but fail to provide actionable details. They are often difficult to measure and validate performance against these requirements. Clients may have different understanding of what is meant by vague terms or concepts. Let's look at a couple of such requirements. Ensure that the application provides a responsive and smooth user experience with minimal delays. Here, responsiveness refers to the speed at which the application should respond. Is it 1 second, 2 seconds, or 10 seconds? Similarly, ensure that the application remains available. When we say remains available, it means the system should remain available, but for what duration? Is it 10%, 20%, or 100% of the time? So such details are not mentioned here, so it is not very clear. So we should always gather quantitative performance NFRs. Quantitative requirements are specific and measurable that define the expected performance characteristics of a system under various conditions. These requirements enable performance testers to design a relevant test scenarios, execute tests, and report on performance results accurately. Let's explore a couple of such requirements examples. The system shall have an average response time of less than 2 seconds for 95% of user requests during peak load conditions. That means the client is expecting less than 2 seconds of response time for 95% of their user requests. Another example, the application should be available 99.9% of the time. Here, they are clearly mentioned that the system should be available 99.9% of the time. Gathering such quantitative requirements will provide clarity in evaluating a system performance and determining whether it meets its performance objectives. Now let's explore frequently gathered different types of performance NFRs. Response time. This requirement specifies the maximum allowable response time for crucial user actions or transactions. For example, the login process should be completed within 2 seconds. Throughput. Throughput in performance testing refers to the rate at which a system or application can process a specific number of transactions or requests or data within a defined time period. This throughput requirement defines the desired data transfer rates that system should achieve. For instance, the system should handle a minimum of 1000 transactions per minute during peak usage. Concurrency. It defines the maximum number of concurrent users or connections the system should support without performance degradation. For example, the system must support 5000 concurrent users without a significant drop in response times. Scalability. Describe how system should scale with increasing load or user demand. For example, the system should be able to scale horizontally to accommodate a 50% increase in concurrent users within 10 minutes. Basically, scaling can be done in two ways: horizontal scaling or scale out. In this type of scaling, they will add more servers to a system to distribute the load and handle increased traffic. Another way is vertical scaling or scale up. Here, they will increase the capacity of a single server by adding more resources such as CPU, memory, and storage. Resource utilization. This requirement specifies acceptable levels of resource utilization. For example, CPU utilization not exceeding 80% during peak loads or memory consumption not exceeding 90%. Geographic considerations. If the system serves users in multiple geographic regions, then there will be a different requirements related to geographic locations. For example, user interactions in North America should have a maximum response time of 1.5 seconds, while those in Europe should be under 2 seconds. Considering geographic factors in performance testing helps organizations ensure that their systems and applications deliver consistent, responsive, and reliable experience to users across different regions. These are some of the performance testing NFRs, and additional requirements may be specified based on the project needs. Please feel free to post your questions in case anything is not clear. Now let's explore the different types of requirements that should be gathered during the study and gathering phase in the performance testing lifecycle. Many companies prepare a non-functional requirements questionnaire document outlining the requirements that client needs to provide to the performance testing teams. In case the client requires clarification regarding the document, a meeting will be arranged for discussion. If there is no such questionnaire document, the performance testing team will send an email to request the necessary non-functional requirements related to performance testing. In certain situations, a meeting will be arranged to collect the required NFR through discussions and collaborations. As I explained in the previous slides, we typically collect all the performance testing requirements related to response time, throughput, concurrency, scalability, resource utilization, and geographic considerations. Additionally, it is crucial to collect the business flows or use cases. These business flows will serve as the basis for validating aspects such as application response time, throughput, concurrency, scalability, and more. So in the upcoming video, we will explore the procedure for identifying the right business flows within the applications. We must collect details about both production and performance testing environments. We should gather information regarding the number of servers, hardware specifications, software configurations, installed software versions, and more. This data is essential for identifying any disparities between the production and testing environments. This is particularly significant as it allows us to conduct testing that aligns precisely with the capabilities of the testing environment, ensuring accuracy in load testing scenarios. If the system relies on third-party services or APIs, we need to understand the performance expectations for these integrations. At times, These external dependencies can affect timelines for performance testing, especially when multiple teams are competing for third-party systems to complete their planned activities. In such situations, we will collaborate with service virtualization team to create a virtual replica of the third-party service within our environment. This approach eliminates the need for third-party dependencies. Several service virtualization tools are available in the market like CA Lisa, Mountbank, Hoverfly Cloud, etc. Again, depending on the requirement, we may gather some additional performance-related NFRs as well. Finally, we will explore some of the challenges encountered during the requirement gathering process. Gathering performance NFRs can be challenging due to various factors. Some of them are like the complexity of modern software systems, evolving technology landscapes, and stakeholder expectations. Stakeholders may provide high-level or vague performance expectations, such as the system should be fast. These ambiguous requirements require further clarification to be useful for performance testing. Gathering accurate NFRs requires active participation from various stakeholders, including business owners, users, developers, and testers. Insufficient engagement of stakeholders can result in missing or misaligned requirements. In some situations, stakeholders may change their performance expectations as the project progresses. This can result in scope creep and create challenges in establishing consistent non-functional requirements. In cases where an existing system or application is being replaced or upgraded, there may be no clear baseline or no performance baseline data available. This will also create a challenge when evaluating the performance of the upgraded software or hardware. Companies may lack personnel with expertise in performance testing. This can hinder the ability to define realistic NFRs and select appropriate performance testing methodologies. Gathering historical performance data or usage patterns is essential for setting realistic performance non-functional requirements. If such data is unavailable or incomplete, it can be challenging to estimate user loads or usage scenarios accurately. When working on complex systems or legacy applications, team may have incomplete knowledge of the entire system's architecture and dependencies. This could present a difficulty in accurately assessing performance impacts. Gathering performance NFRs is a critical step in performance testing as they ensure that the final product meets user expectations for performance and reliability. It requires a collaborative and iterative approach to address these challenges. So that's it for this video. Thank you so much for staying till the end and supporting me. I hope you understood all the concepts in this video. In case any specific concept is not clear or require more detailed information, please feel free to mention it in the comment section. All the video notes have been uploaded in GitHub and you can find the link in the description. If you are new to our channel, please consider subscribing and also like and share this video so that others will also get benefited. I'll see you with the next video in module 4. Until then, take care, stay safe and keep learning.